if I say what is the correlation coefficient of two-dimensional normal distribution, then maximum number of students gives the correct answer, which is given by rho. Okay, we all know that the correlation coefficient of bivariate normal distribution is rho. But how to prove it? That the correlation coefficient of bivariate normal is rho. Okay, so to prove this is rho, we start with the definition of correlation coefficient. What is the definition of correlation coefficient? Correlation coefficient is defined as rho xy. These are two variables. It is also known as rho xy. Okay, or it is also known as simply rho. And the definition of rho is covariance of x and y by sigma x into sigma y. And this is cov xy, that is the covariance of x and y, and this is standard deviation of x and standard deviation of y. Now we start with cov xy. We first write cov xy. The definition of covariance of two random variables x and y, which is given by expectation x minus mx into y minus my, right? Where mx and my are the mean of x and mean of y. Now, what is the definition of this expectation? Which is given by integration. This is obviously double integration. One integration on x and another integration on y. This is x minus mx into y minus my into fxy dx dy. What is fxy? Fxy be the joint PDF of x and y. Here the joint PDF of bivariate normal. What is the joint PDF of bivariate normal? We write here the joint PDF of bivariate normal distribution with 5 parameters: mx, my, sigma x, this is sigma x, this is sigma y, and this is rho. These are the 5 parameters of x and y. And we write here the value of fxy directly, and this is given by, this is minus infinity to infinity, and this is also minus infinity to infinity. This is x minus mx into y minus my 1 by 2 pi sigma x sigma y into root 1 minus rho square. And this is exponential minus half into 1 minus rho square into this is x minus mx by sigma x whole square minus 2 rho x minus mx by sigma x into y minus my by sigma y plus this is y minus my by sigma y whole square, right? And this is dx dy. This is the definition of expectation, and this is the value of fxy from this to this. Okay, now we make a substitution here. We make the substitution. This is x minus mx by sigma x, this is u, and y minus my by sigma y, this is v. And clearly from this substitution we get that dx, this is sigma x du, and dy, this is sigma y dv, right? Now substituting these two value, we get this integration as this is given by integration minus infinity to infinity, and this is also minus infinity to infinity. And here range is not changed because u and v are in the same range. Now put x minus mx, the value is u sigma x, and y minus my, this is v sigma y. Okay, and we write here this is 2 pi sigma x sigma y root 1 minus rho square, and this value is written as e to the power minus 1 by 2 into 1 minus rho square into u square minus 2 rho u v plus v square, and dx dy, this means sigma x sigma y du dv. This is sigma x sigma y du dv. Right, now we cancel out this sigma x, this sigma y, this sigma x, this sigma y, and getting the result as this is sigma x sigma y by 2 pi into root 1 minus rho square, and this is minus infinity to infinity, also minus infinity to infinity, u v and e to the power minus 1 by 2 into 1 minus rho square into, we write this term as u square minus, this is 2 u into rho v, because this is 2 rho u v, so we adjust this term as 2 u, we first write u and then rho v, and we add here rho square v square to make it a perfect square. Now we write v square, then subtract rho square v square, and here du dv. Okay, so this is, if we write, this is of xy by sigma x sigma y. We write this sigma x sigma y in the lower of xy, right? And then we get, this is the definition of rho xy, right? And the right side is 1 by 2 pi root 1 minus rho square. This is double integration, and this term is u v e to the power minus 2 into 1 minus rho square, and this is given by u minus rho v whole square plus 1 minus rho square into v square. Okay, and this is du dv. Now if we write this exponential into two terms, then we get the result as 1. This is 1 by root 2 pi, and this is integration minus infinity to infinity, and this is given by v and e to the power minus 1 by 2 into 1 minus rho square into this term. So 1 minus rho square and 1 minus rho square cancel out, so we get only e to the power minus half v square. Okay, and another term we write 1 by root 2 pi, this is 1 minus rho square, and this is integration u, this is equal to minus infinity to infinity, u into, here u remains because here we write only v, so u into e to the power minus 1 by 2 into 1 minus rho square into u minus rho v whole square. This is dv, we first write, du, and then we write dv, because here we treat the integration with respect to u, but v is treated as constant, so we write here dv. Okay, now to integrate this integration, we put here another substitution which is given by u minus rho v by root 1 minus rho square, and this is equal to k we put, right? And then clearly du, this is given by root 1 minus rho square into dk, and the value of u, which is given by u, this is root 1 minus rho square k plus rho into v. Okay, so we put the value of u and value of du here. We get the integration as, this is rho or rho xy, this is the left hand side, and from right hand side we write that 1 by root 2 pi, the integration is minus infinity to infinity, this is v into e to the power minus v square by 2, this is the term, and for this term we put here the value of u, this is, we first write the constant term, this is 1 by root 2 pi into root 1 minus rho square, and this integration is given by, we put the value, this is root 1 minus rho square into k plus rho into v. Okay, and this is becomes here we write, this is minus infinity to infinity, e to the power, this is given by minus k square by 2, and the value of du, is this. Okay, so we write this as, this is, we first write e to the power minus k square by 2, and the value of du, this is root 1 minus rho square into dk, and dv is here. Okay, this is one integration, right? So we get the value of rho 1 by 2 pi integration minus infinity to infinity v e to the power minus v square by 2. From the first term, if we multiply, then this term and this term cancel out. Okay, and we get the result as, this is 1 by root 2 pi into, here we get root 1 minus rho square for the first term, and this is integration minus infinity to infinity k e to the power minus k square by 2 dk. Okay, and for the second term we get also this term and this term cancel out, so for the second term we get rho by root 1 minus, root 2 pi, because 1 minus rho square cancel out, and this is integration minus infinity to infinity e to the power minus k square by 2 dk, and dv is here. Okay, now for the first term, this integration is obviously, this is the odd term. Okay, because k into e to the power minus k square by 2, and the integration of odd function in the range minus a to a fx dx, this is obviously 0, we know. Okay, so we put this value is equal to 0, right? And for the second term, this is integration of type, this is 1 by root 2 pi integration minus infinity to infinity e to the power minus k square by 2 dk, and clearly this value is equal to 1, because we know that this is integration minus infinity to infinity phi k dk, this is obviously 1. What is phi k? Phi x is normal 0 1, this is standard normal distribution. Okay, so we get from this result, this is 1 by, this is not 2 pi, this is root 2 pi, root 2 pi integration minus infinity to infinity. This is v e to the power minus v square by 2, and this integration is 0 and this integration is 1. Okay, so we get the result as, and we get here another v. We forget to write it. This is v in the second term. So we get 0 plus rho v dv, right? Because this integration is 1. Now we get another integration which is given by, what is the integration? This is 1 by root 2 pi integration minus infinity to infinity, and if we delete 0, then we get here rho, and this is v square into e to the power minus v square by 2 dv. Okay, now we try to integrate this term. How to find this integration? We put v square by 2, this is equal to z, and this gives v dv, this is dz, and we get the range of integration. Sorry, we first change the range of integration by using the property if fx dx, this is minus a to a, is such type of integration where fx is even function, then we can write this integration as 2 into 0 to a fx dx. Okay, and clearly this is an even function, so we change this integration by 2 into this, and the range is 0 to infinity. Now if we substitute this substitution, and the change is same from 0 to infinity, and we get the result 2 rho by root 2 pi integration 0 to infinity. Here we get v dv, this is dz, and e to the power minus z, right? And another v remains, so we put the value of v, which is given by root 2z. So here this is 2z. Okay, and clearly root 2 and root 2 cancel out, so 2 rho by root pi integration 0 to infinity e to the power minus z, and this is given by root z, so we write z to the power half dz, and we get this is z to the power half. This means 3 by 2 minus 1 dz. Why we write this type of integration? Because we know that gamma function, that is gamma n, is given by integration x equal to 0 to infinity e to the power minus x into x to the power n minus 1 dx. This is the gamma integration. So clearly from this integration we get 2 rho by root pi, this is gamma 3 by 2. Here we use the property of gamma n, this is n minus 1 gamma n minus 1. Also we use the result gamma half, this is root 5. Okay, so we first write this is 2 rho by root 5 into half gamma half, and using the value of gamma half, this is root pi, so we get 2 rho by root pi into half into root pi. So root pi cancel out, 2 cancel out. So we get the value of rho or rho xy. Rho xy is rho. Okay, so we prove that for the bivariate normal distribution, rho is the correlation coefficient between two random variable x and y. Okay, very simple but common but intellectual problem of normal distribution. Thank you.